So today we are going to address sampling methods. So far, we've done a lot of analysis of data that was provided for us. Nobody questioned the data. We didn't say where did it come from. We just took it and did some good mathematics with it. Some of it was easy, some of it was not so easy, but we didn't question where the data came from. And that is extremely dangerous. If you don't know where the data came from, if your data that you are trying to analyze is not representing whatever population you're interested in, then no matter how good the analysis is, the end results are going to be bad if the data was not collected properly. Okay? So I consider this topic to be probably the most important topic in statistics, which is to question how was the data collected, how was it selected, does it reflect whatever question you have, does it reflect the population of interest? These are questions we need to answer today. So let's say you're interested to know the percentage of students who are taking statistics who scored 5 on the AP last year. Your population of interest would be all students in the US who took statistics last year. In fact, who took the AP exam last year. So that would be your population of interest. And so your sample clearly is going to be a subset of your population of students who took the AP stats last year. And you're going to find out if they got 4 or more or didn't. The question here is, why do we say population of interest? Just because I am interested in how students perform on the AP stats, it doesn't mean I go to every kid in any high school and start asking them questions. Anyone, for example, who did not take stats shouldn't be asked. Anyone who's not in high school, let's say, shouldn't be asked. Whether you're a male or a female, it doesn't matter, because the population of interest would be the student who took AP statistics last year. Okay? Another example, let's say you're interested to know the percentage of males that smoke in the US. Is it 10%? Is it 15%? Your population of interest wouldn't be any human being who lives in the US. It would be the population of males. Why? Because your question pertains to males only. So you're not going to ask females, for instance, because that wasn't the question. It has nothing to do with the question. You're not going to ask toddlers. You probably are not going to ask a 17 years old if your age of focus is, let's say, 18 to 50, let's say, right? So we don't just say population, but we say population of interest. Now, in order to collect data, you have two methods. The first method is to take your entire population and just go and ask them one by one. It's called census, right? So let's say you're interested to know what percentage of students scored more than 5 on the AP stats. You could literally go to every student that took that class and ask them, did you get a 5 or more or not, right? The problem with that is, generally, it is very time consuming. It might take you 2 years to finish. By the time you finish, your population changes on you. Most of those kids now are in college, and kids who didn't take it now, they just took it, right? The population is fluid. It changes. So it's very time consuming. The population changes because it is time consuming, and also it is very costly. It's very costly to ask every individual that lives of some population about a particular question. So just doing a census is not necessarily effective at all. Okay? And by the way, a census doesn't mean you're going to get the right answers. Again, because people lie, people change, people pass away, it's time consuming. It's just, there are all sorts of problems with census. A better method is just to pick a sample. And it doesn't mean you just pick any sample. A sample is just a subset of the population. that sample has to be a good sample. And I write good, but never write it, okay? On the AP or some test, don't say good. You got to explain what do you mean. So what is a good sample, so to speak? A good sample is a sample that reflects the population of interest. That's all. If it doesn't reflect the population of interest, it's not a good sample. So I know most people are visual learners, so I'm going to share with you an example. So let's say I have, excuse me for a second. I made a big bowl of soup, and I'm having guests, and I want to taste it. So I took a teaspoon or maybe a small bowl, okay, and I eat this. As you can imagine, let's say the texture of this sample is most likely the texture of that big bowl. The salt, if it is salty, if this feels salty, so as this one. If this is very liquidy, so as this one. If this has less vegetables, so as this one, assuming you mix first before you take the sample, right? I would say this is a great sample of this population, so to speak, okay? A bad sample would be, let's say, a fruit salad. You made a big bowl of fruit salad. Maybe it has 5 fruits, and you are picky. You like strawberries, so your sample has more strawberries than the rest. Maybe strawberries constitute 20% of the salad. You know, you have 5 fruits and each one is about 20%. But in here you may have 40% strawberries and no bananas when you actually have bananas here, right? So that wouldn't qualify as a good sample unless you are very careful. You mix well and you pour a little bit. Most likely it might become a good sample, but this is something to worry about. And I thought of sharing with you this example will shed some light on what is visually what is a good sample versus a bad sample. So let me write the word sample. So let's get to it now. I'm going to start with bad sampling methods. And there are plenty out there, but I'm going to share 3 with you. These are the ones you see most. First one is convenient sampling. It says the one who samples conveniently selects. Let's say you have a question that you want to ask the student body. Let's say we have 1,000 students, and you are interested in answering a question from the student body. And you don't want to ask all 1,000. It takes time. You may not find them. It's just not good, right? Census is not necessarily a good idea. You want to take a sample. Well, let's say you are in stats class and there are 16 of you, and you turn around and say, oh my God, I have 15 right here. Let me just ask them what they think. That's a convenient sampling. It is convenient. You could get the answers very fast, assuming they tell you the truth. But it's not a good sample because the 15 classmates in your class of 16, you're the 16th one, does not represent the student's body, does it? Right? So that is called a convenient sample. A voluntary sampling is basically individuals who self-select. And this is, you see this all the time. People make this mistake all the time, and I really hope it's actually in schools. You know, when schools gather data and they give you answers, oftentimes they do it this way. You see, you get surveys, and people fill them, and others don't fill them. It's like, I just need 50. So if we send it to 500, hopefully 50 will respond. Well, that's a voluntary sampling. That's a very bad way to sample. And therefore, if you have that sample in your hand and you do good analysis on it, you're still going to have bad results. Bad results means results that are not truthful, right? They don't represent the actual truth that nobody actually knows, right? So I'm going to share with you an example. This is a true example. Back in the 80s, I was watching TV, and the TV anchor had a question for the audience, for the people watching TV, and the question was this. and the population of interest then was the parents, people with kids. Okay, and he said, if you are parents and have kids already, if I push back the clock to the time when you didn't have kids, knowing what you know right now, would you have kids? Right? If you know, if you knew what you know now, would you have kids or you wouldn't have kids? And the TV anchor shared the results, and it was shocking. So many parents said, I would never have kids again. And that TV station actually got a lot of hits. That was a voluntary sampling. What happens with voluntary sampling is when you ask a question and you allow people to self-select, you know who responds generally? Those who have extreme views on the topic. For instance, in the example that I just shared with you, people who care so much about their kids and say to themselves, how dare you even ask the question, most likely responded. Similarly, those who hate kids, excuse me, that's a strong word, those who don't like kids at all are the ones who responded. The majority of the people, the 85 people in the middle, didn't even care to call the TV station because they're neutral. Not neutral that they don't care about kids, they don't have strong views on whether or not they should have kids. And I would add another small population that I can guarantee you didn't answer: mathematicians, because they know it is a voluntary sampling method, and it is a very bad way to sample. So I didn't, even though I was young, I didn't. I knew it was a bad way to sample. So what happens? The TV station got a lot of heat from the community, and they hired statisticians and a statistician, and they did it the proper way, right? And we don't know what the proper way yet. And it turned out most people, I forgot, but it was like 96% or more, said, I would never trade my kids. I would never change my life. I'm happy with my kids. I'm so glad I had my kids, right? So be careful of voluntary sampling method. A third one, this is also very, very common. And you know why is this common? Because of this word. People associate the word random with fair. It's random. I did it randomly. What's the problem? Fair, right? They think it's fair. And I'm going to show you quite the opposites, okay? I'm going to do it randomly. So what's the problem? I didn't conveniently pick people. I didn't ask people to self-select. I randomly chose the group, my sample. I randomly chose it, and I'm saying it is a bad one. And I'm asking you, what are you talking about, right? Those people's like, what are you talking about? It's it's a random sampling. What's the problem? Yeah, there is a huge problem. I'll give you a very simple example, maybe two examples. Before you were born, every city used to issue what we call yellow pages. So one day I wake up, once a year, I wake up, I open the front door, and there is this giant book. It's called Yellow Pages. The top and the bottom cover are yellow, and they have all the phone numbers of individuals and businesses in your little area or city or whatever. So I look for my name, and it's right there. My name is right there on page 529, and my phone number is written. It's right there. And so somebody, let's say, wants to sample, and they said, okay, I'm going to do it randomly. I am very good. These are bad. I am very good. I am going to take the yellow pages, and I'm going to randomly open the book, and let's say I got page 23, and then I'm going to randomly pick a row, and let's say it's row 29, and I'm going to randomly pick a name, and here you are. So I'm going to interview you because I did it so randomly, and there should be no problem with this approach. There is a huge problem. The problem is not every individual is listed on the yellow pages. For example, at the time, we didn't have cell phones, but people had landline, right? So if you were poor, you didn't have a phone at home, you were not listed because you don't have a phone. So now you are marginalizing or skipping a population, a part of your population called, let's say, poor people, or just people who we don't have phone. Maybe they're not poor, but they choose not to have a phone. Okay. Another population that you're ignoring, a subset of your population that you're ignoring, is famous people. You know, like very wealthy people, actors, big sports players. They don't want their names. I mean, they'll be bothered all the time. People will call them all the time, right? In fact, what they do is they pay so their name is not listed. So think about it. All these people who don't want to be on the yellow pages, they actually have to pay the city, forgot what the amount was, probably $100, so that their name and their phone number are not listed on the yellow pages. Now, even though you picked a random page and a random name to call that person, because now that person is part of your sample that represents your entire city, it's still not a good one. So I would say randomness is not fair. I would say random leads to bias. And I'm going to spend some time on this word, okay? So this is not a good way to sample. Or maybe you went to the streets at 10 a.m. and you randomly asked people some question. You don't differentiate between males and females, young and old, black and white. People you know, people you don't know. You randomly asked people, sampled people, right? That's still a bad idea because you have at 10 o'clock, all people who are working are in the office, right? So you are ignoring a large size of the population. You're also ignoring people who are home and they work from home. You're also ignoring anyone who's, I mean, 10 o'clock is not noon. Noon, maybe people are going out for lunch, let's say, right? There are all sorts of problems with just going out to the streets at 10 a.m. on a Monday and asking people questions, okay? So what is bias? I said randomness leads to bias. What is bias? Bias doesn't mean what you might think. There are two students in my class. They have similar paper. I gave one of them 9 out of 10. The other one I gave 8. And then the student comes to me, he's like, Mr. Whatever, you're biased. Why? Well, we have the same paper and you gave her 9 and you only gave me 8. That's not bias. Bias is when you systematically, I'll write it down. Bias is when you systematically favor an outcome over another. So let's say we have kids with similar papers and I systematically, almost every time, I give student A 9 out of 10 and I give student B 8 out of 10 and they are similar papers, right? I do it all the time. So when you systematically favor an outcome over another, that is called bias. And I believe when you sample randomly, you are being biased. So be careful with this method of sampling. So let's get to a couple of good ones because it's important to know what not to do, but it's also important to know what to do. So there are more than 3, okay? There is systemic sampling, for example, which I didn't write. So I'm just going to address 2 or 3. Maybe I'll just do 2. The video is getting long. The building block of a great sampling method is what we call a simple random sample. And it has, we call it SRS. When you see SRS, That means simple random sample. Now, don't confuse simple random sample that has the word random in it with random sampling. This is a bad way to sample. This is an excellent way to sample. So what is a simple random sample? It is when every member, could be a person, could be a rat, could be every member of the population of interest, has an equal chance of being picked. So let's say I have a population of 1,000, and I want to pick 10. I want to pick 10. So my sample is 10. Take a sample. I'm not writing well. Take a sample of size 10. And this is the population. So basically, what's the probability that I pick any one of my population? Let's say my sample is 100. Let's keep it nicer. My sample is 100. And maybe my population is 10,000. So I really don't want to talk to 10,000 people. Okay, so what's the chance of picking any member? Well, clearly it's 1 out of 100. This is my sample, okay? I don't look here, I just look here. This is my sample. So let's say I pick John. First one is John. John has 1 out of 100 chance of being picked. Make sense? Now, I go back to the drawing board and I pick the next person. So first person first. Now, when I go to the second person, I only have 999 left. So the probability of picking Jane, now is 1 over 99. You see how the probability changed? That's not a simple random sample. So what you should do instead, you pick one, you get John. Then you put John back into the drawing board. Go back here. Now everybody has another 1 out of 100 chance of being picked. Then you pick, let's say, Jane. Let's say you pick John again. You just push him back again and start over. You've got to put back the member you picked so that the probability doesn't change. Are you with me? So that's what we mean here by every member of the population has an equal chance of being selected. Okay? So basically we say draw with the replacements. You don't draw without replacement, like put John here. No, you got to put him back here and start over. And yes, you are risking picking John again, but that's okay. You just do it again, right? Until you pick your 10 members or whatever number you're looking for. So that is what is a simple random sample. Now, I said this is the building block for all samples, good samples that are coming up. When I say building block, it doesn't mean it's simple or silly. It's powerful, actually. It's just this and that and next one and next one. Generally, they're based on a simple random sample. So the next one is stratified sample. I said it is a simple random sample, first of all, with strata. So let's say you have 1,000 students. Okay, you have 1,000 students, and you want to select 10 members for some committee. 10 committee members. Well, clearly you could just do a simple random sample. Pick the first one, put him or her back into the pool, select next one, put that person back in the pool, and keep doing it until you hit 10. But let's say this school, I don't know if I said school, let's say this school has 750 females and has 250 males. It would not be a good idea just to do a simple random sample. It would not be a good idea to pick one, whether it's a male or a female, write their name and put them back in the pool, pick second, because most likely See, these numbers are not close, right? You have 3/4 of the population that is females, and only 25% are males. Maybe this is not a good number. Let me pick 800 and 200. You'll see why. So we have 4/5 are females and 1/5 are males. So maybe for this committee, you should have 2 males and 8 females instead. So what you do first is you stratify your population by gender. Why? Because gender is an issue here. Makes sense? You don't always stratify by gender. Sometimes you stratify by grade level or by age or by borders versus non-borders, right? But in this particular example, let's say you want a 10 committee members sample that represents the population of interest. You can't just use a simple random sample. You may end up with 5 males, 5 females, and that's just not fair. Even though you did everything right. In fact, you did simple random sample, but it's still a bad idea. First, you stratify or you split by gender first, and then out of these 800, you use a simple random sample to pick 8, and out of these 200 males, use another simple random sample to pick 2. Why? Because you want 1/5 to be males and 4/5 to be females. I'm still using a simple random sample, but first I stratified my population of interest by gender. Does that make sense? Do you see how this is built on that? Okay, and if you do a diagram, you should call this SRS1, SRS2, right? You have 2 simple random samples. All right, I am going to actually end here, because if I keep going, I'm gonna make this video even longer by at least 5 minutes. So I'm gonna stop here. Well, let's just stick with these 2 good ones. Maybe next time I'll do one with cluster sampling and systematic sampling. How about that? All right, take care.